As we age, a fundamental change occurs deep within our bodies. The vital elasticity of our heart, blood vessels, skin, lungs, and other tissues significantly decreases. This process, often referred to as physiological stiffening, is a fundamental part of how the human body ages. To understand why tissues lose this flexibility, we must look at changes happening at the cellular and molecular levels. First, there is the degradation of elastin. Elastin is a highly flexible protein that allows tissues to stretch and recoil, much like a rubber band. Over time, these elastin fibers naturally break down, and fray in adult bodies are unfortunately very poor at producing new elastin to replace them. Simultaneously, significant changes occur in collagen, the protein that provides structural strength. While elastin decreases with age, collagen tends to accumulate. More importantly, aging causes collagen fibers to cross-link or bind together rigidly, turning previously pliable tissues into stiffer structures. This stiffening process is further accelerated by Advanced Glycation End-products, or AGEs. Over time, sugars in the bloodstream bind to proteins and fats, forming these compounds, which accelerate the rigid cross-linking of collagen, making tissues even stiffer. The cardiovascular system is one of the areas most impacted by this loss of elasticity. When the aorta and other major blood vessels stiffen, they cannot expand easily to absorb the force of blood pumped from the heart. This forces the heart to pump harder, which is a primary reason why blood pressure often increases with age. Furthermore, the heart muscle itself, particularly the left ventricle, becomes stiffer and thicker. Because a stiff heart cannot relax easily between beats, it struggles to fill completely with blood, making it less efficient at circulating blood, especially during physical exertion. Heart valves, which rely on flexibility to open and close smoothly, can also accumulate calcium deposits and stiffen.
This same loss of elasticity happens throughout the entire body. The elastic tissue in the lungs deteriorates, meaning the lungs do not recoil as well after expanding. This reduces air exchange, making vigorous exercise feel more taxing. In the skin, the breakdown of elastin and collagen networks in the dermis is the primary reason skin sags, wrinkles, and loses its youthful bounce. Additionally, the connective tissues around joints, namely tendons and ligaments, become more rigid, decreasing overall range of motion and flexibility. While physiological stiffening is a natural part of aging, certain lifestyle factors like smoking, a high-sugar diet, and chronic stress can rapidly accelerate it, making research into preserving tissue elasticity vital for future health outcomes.